we have another parabola problem here, and we're told what the vertex and the focus are. And we're told to find everything else about the parabola and draw it in this graphing window right here. So let's work through these pieces one at a time. I think the most important thing to establish at the very beginning of a problem like this is what direction is your parabola going in, right? Is it a vertical parabola, up or down, or is it a horizontal parabola that opens left or right? Well, let's take a look at the vertex and the focus, and that'll become more clear, I hope. So the vertex, this guy, is located at 1, -1. That's going to be right around here. And the focus is located at -1.5, -1. So -1.5, -1 is this point right over here. Okay? So now, if that's our focus, and that's our vertex like this, right? Let me just label those, focus and vertex. Remember, the parabola turns around at the vertex. That's its turning point, and it wraps around the focus. So you can see what I'm talking about here is going to be something like this. Okay, it's a horizontal parabola. That's all I need to draw for now. That's going to get me going. What I need to establish first, though, is the focal length. So what is this distance right here? That's P, the focal distance, or the focal length. Well, 1, 2, I'm counting grid spaces, and it looks like 2.5. Okay, now that's P. The focal diameter is defined as 4P. Well, 4 times 2.5 is easy, that's just 10. So the focal diameter of this thing is 10. Now, what's next? I want the equation for the axis of symmetry. Well, that's not too hard. The axis of symmetry, if you recall, is just the line connecting the focus and the vertex. And it goes forever in both directions. So what kind of a line am I talking about here? Well, this is a horizontal line, so we say y equals, and then we look at the y values of the focus and vertex. That's going to be -1. So there's your equation for the axis of symmetry. And I'm going to start cleaning this graph up a little bit just so we can keep on drawing things here. The equation of the directrix. Well, what is the directrix? I hope you remember this one. This is another line, and it's outside the parabola completely, and it runs perpendicular to the line of symmetry. And not only that, if this distance is P right here, the directrix is another distance of P beyond the vertex. So count another 2.5 units. That's going to place you somewhere around here-ish. Okay, now that's a vertical line. In this case, it's going to be x equals 1 plus 2.5 is 3.5. Okay, so x equals 3.5 looks like where this line is landing. And now it's time to start talking about the equation of the parabola. I think we have enough pieces to put this all together. Because this is a horizontal parabola, okay, it's going to have an equation that is structured like so. Y minus k squared equals the focal diameter times x minus h. Okay, now we just plug in some of those things we know, especially from the vertex. We know what h and k are, right? There's h, there's k from your vertex. Well, h is 1, so I can replace this x minus h with an x minus 1. And k is -1, so I'm going to replace negative k with positive 1 right here. Don't forget that sign flip. And then the last bit is the focal diameter, which is 4p, that's 10. Okay, so we're going to replace 4p with 10. Now, one more piece about this. Because this parabola is opening to the left, this is actually a -10. Okay, that's an important point right there. If it were opening down, it would also be a negative. But P is considered negative when you have an opening to the left or opening down. It's considered positive when you're opening up or opening to the right. So we have to change that 10 to a -10 here. And let's see what else. Well, now it's time to draw this thing. And I've got most everything that we need. Here's the directrix on the far right. Okay, that's our directrix. And we have the focus. I don't need, for this picture, it didn't really want the vertex, so we're going to leave that out. I'm going to leave some of these other bits out here. What else is needed? I need the latus rectum, which, if you recall, that is the line parallel to the directrix, which runs through the focus. So a line like this. And the length of that line is simply, well, that's the diameter of the parabola at those points. So I'm going to make sure this thing is 10. I'm going from -1 up to +4, and from -1 down to, let's see, I'm counting down 5, down to -6. Okay, now that's really useful, because if I plot this parabola using the computer program, it wants a point at the vertex, that's great, and then it wants a point somewhere else. So you can just drag that point to meet up with the lattice rectum right there, and there you go, a perfectly drawn left opening horizontal parabola.